From its size and shape to its orbit, to how it might further humanity across the stars, join us as we explore Deimos, Mars's moon. Number 8. History. Deimos was discovered by Asaph Hall III at the United States Naval Observatory in Washington, D.C. on August 12, 1877 at about 7:48 UTC, given in contemporary sources as August 11, 1440, Washington Mean Time, using a pre-1925 astronomical convention of beginning a day at noon. So 12 hours must be added to get the actual local mean time. Hall also discovered Phobos on August 18, 1877 at about 9:14 GMT, after deliberately searching for Martian moons. It is named after Deimos, a figure representing dread in Greek mythology. The names at first spelled Phobos and Deimus were suggested by Henry Madan, 1838 to 1901, Science Master of Eton, from Book 15 of the Iliad, where Eris, the Roman god Mars, summons dread, Deimos, and fear, Phobos. Hall recorded his discovery of Phobos in his notebook as follows. I repeated the examination in the early part of the night of 11th August 1877, and again found nothing. But trying again some hours later, I found a faint object on the following side and a little north of the planet. I had barely time to secure an observation of its position when fog from the river stopped the work. This was at 2:30 o'clock on the night of the 11th. Cloudy weather intervened for several days. On 15 August, the weather looking more promising, I slept at the observatory. The sky cleared off with a thunderstorm at 11 o'clock, and the search was resumed. The atmosphere, however, was in a very bad condition, and Mars was so blazing and unsteady that nothing could be seen of the object, which we now know at the time was so near the planet as to be visible. On 16 August, the object was found again on the following side of the planet, and the observations of that night show that it was moving with the planet, as if a satellite was near one of its elongations. Until this time, I had said nothing to anyone at the observatory of my research for a satellite of Mars. But on leaving the observatory after these observations of the 16th, at about 3 o'clock in the morning, I told my assistant George Anderson, to whom I had shown the object, that I thought I had discovered a satellite of Mars. I told him also to keep quiet, as I did not wish anything said until the matter was beyond doubt. He said nothing, but the thing was too good to keep, and I let it out myself. On 17 August, between 1 and 2 o'clock, while I was reducing my observations, Professor Newcomb came into my room to eat his lunch, and I showed him my measures of the faint object near Mars, which proved that it was moving with the planet. On 17 August, while waiting and watching for the outer moon, the inner one was discovered. The observations of the 17th and 18th put beyond doubt the character of these objects, and the discovery was publicly announced by Admiral Rogers. Number 7. Orbits and rotations. Deimos' orbit is nearly circular and is close to Mars's equatorial plane. Deimos is possibly an asteroid that was perturbed by Jupiter into an orbit that allowed it to be captured by Mars, though this hypothesis is still controversial and disputed. Both Deimos and Phobos have circular orbits which lie almost exactly in Mars's equatorial plane, and hence a capture origin requires a mechanism for circulating the initially high eccentric orbit and adjusting its inclination into the equatorial plane, most likely by a combination of atmospheric drag and tidal forces. It is not clear that sufficient time was available for this to have occurred for Deimos. As seen from Mars, Deimos would have an angular diameter of no more than 2.5 minutes. 60 minutes make 1 degree. 1/12 of the width of the moon is seen from Earth, and would therefore appear almost star-like to the naked eye. At its brightest, full moon, it would be about as bright as Venus is from Earth. At the first or third quarter phase, it would be about as bright as Vega. With a small telescope, a Martian observer could see Deimos' phases, which take 1.2648 days, Deimos' synodic period, to run their course. Unlike Phobos, which orbits so fast that it rises in the west and sets in the east, Deimos rises in the east and sets in the west. The Sun's synodic orbital period of Deimos is about 30.4 hours, exceeds the Martian solar day, Sol, of about 24.7 hours by such a small amount that 2.48 days, 2.41 sols, elapse between its rising and setting for an equatorial observer. From Deimos rise to Deimos rise, or setting to setting, 5.466 days, 5.320 sols, elapse. Because Deimos' orbit is relatively close to Mars and has only a very small inclination to Mars' equator, it cannot be seen from Martian latitudes greater than 82.7 degrees. Deimos' orbit is slowly getting larger because it is far enough away from Mars and because of tidal acceleration. It is expected to eventually escape Mars' gravity, which is in contrast to Phobos, who is having its orbit degraded every 100 years, and is expected to be destroyed by Mars eventually and then become its ring. Number 6. Size and structure. Deimos is the smaller of Mars' two moons, being only 9 by 7 by 6.8 miles in size, 15 by 12 by 11 kilometers. Like Phobos, Deimos is a small and lumpy, heavily cratered object. Its craters are generally smaller than 1.6 miles or 2.5 kilometers in diameter. However, it lacks the grooves and ridges seen on Phobos. Typically, when a meteorite hits a surface material is thrown up and out of the resulting crater. The material usually falls back to the surface surrounding the crater. However, these ejected deposits are not seen on Deimos, perhaps because the moon's gravity is so low that the ejecta escape to space. Material does not appear to have moved down slopes. Deimos also has a thick regolith, perhaps as deep as 328 feet or 100 meters, formed as meteorites pulverize the surface. Deimos is a dark body that appears to be composed of C-type surface materials, similar to that of asteroids found in the outer asteroid belt. Before we continue to dive into what Deimos is like, be sure to like or dislike the video. That way we can continue to improve our content for you, the viewer. Also be sure to subscribe, that way you don't miss any of our weekly videos. Number 5. Exploration. Not surprisingly, the exploration history of Deimos is similar to those of Mars and Phobos. Deimos has been photographed in close-up by several spacecraft, whose primary mission has been to photograph Mars. No landings on Deimos have been made. The Soviet Phobos program sent 2 probes to Phobos. In case Phobos 1 succeeded, Phobos 2 could have been sent to Deimos. Both probes launched successfully in July of 1988. The first was lost en route to Mars, whereas the second returned some data and images, but failed shortly before beginning its detailed examination of Phobos' surface, including a lander. In 1997 and 1998, the proposed Aladdin mission was selected as a finalist in the NASA Discovery program. The plan was to visit both Phobos and Deimos and launch projectiles at the satellites. The probe would collect the ejecta as it performed a slow flyby, around 1 kilometer per second. These samples would be returned to Earth for study 3 years later. The principal investigator was Carl M. Peters of Brown University. The total mission cost, including launch vehicle and operations, was $247.7 million. Ultimately, the mission chosen to fly was Messenger, a probe to the planet Mercury. In 2008, NASA Glenn Research Center began studying a Phobos and Deimos sample return mission that would use solar electric propulsion. The study gave rise to the Hall mission concept, a New Frontiers-class mission currently under further study. Also, the sample return mission called Gulliver has been conceptualized and dedicated to Deimos, in which 1 kilogram, 2.2 pounds, of material from Deimos would be returned to Earth. Another concept of sample return mission from Phobos and Deimos is OSIRIS-REx 2, which would use heritage from the first OSIRIS-REx. In March 2014, a Discovery-class mission was proposed to place an orbiter on Mars orbit by 2021 and study Phobos and Deimos. It is called Phobos and Deimos and Mars Environment, PADMA. Human exploration of Deimos could serve as a catalyst for the human exploration of Mars. Recently, it was proposed that the sands of Deimos or Phobos could serve as a valuable material for aerobraking in the colonization of Mars. Because the small Delta V budget of Phobos, a small amount of chemical fuel brought from Earth could be transformed in a very large amount of sand lifted from the surface of Phobos, from a permanent outpost to a transfer orbit. This sand could be released in front of the spacecraft during the descent maneuver, and then resulting in a desensification of the atmosphere just in front of the spacecraft. Number 4. Solar transits. Deimos regularly passes in front of the Sun as seen from Mars. It is too small to cause a total eclipse, appearing only as a small black dot moving across the Sun. Its angular diameter is only about 2.5 times the angular diameter of Venus during a transit of Venus from Earth. Its fellow moon, Phobos, also has a similar kind of solar transit because it is too small that it can't block out the Sun. However, it still creates quite the interesting image. On March 4, 2004, a transit of Deimos was photographed by Mars rover Opportunity, and on March 13, 2004, a transit was photographed by Mars rover Spirit. Number 3. Controversial origins. The origin of the Martian moons is still controversial, which is interesting given how long we've been studying them. Phobos and Deimos both have much in common in regards to their composition and even their shape and size in certain areas. Based on their similarity, one hypothesis is that both moons may be captured main belt asteroids. Both moons have very circular orbits which lie almost exactly in Mars's equatorial plane, and hence a capture origin requires a mechanism for circularizing the initial highly eccentric orbit and adjusting its inclination to the equatorial plane, most probably by a combination of atmospheric drag and tidal forces, although it is not clear that sufficient time is available for this to occur for Deimos. Capture also requires dissipation of energy. The current Martian atmosphere is too thin to capture a Phobos-sized object by atmospheric braking. Jeffrey A. Landis has pointed out that the capture could have occurred if the original body was a binary asteroid that separated under tidal forces. Another hypothesis is that Mars was once surrounded by many Phobos and Deimos-sized bodies, perhaps ejected into orbit around it by a collision with a large planetesimal. The impact on Mars that reaccreted in Martian orbit would be similar to the prevailing theory for the origin of Earth's moon, in which many people believe that a large object smashed into the Earth and the remnants of that impact were caught in the gravity of the Earth and eventually formed into the moon. The irony here is that it's hard to tell which of these theories is true, especially since we're still evaluating the origins of Mars itself. Only through various tests on both planet and the moons can we likely find the truth of what is going on. Number 2. Odd shape. Go ahead and picture in your mind a moon. More than likely you went and pictured the moon that is orbiting the Earth right now, which is fair. When you think of a moon, you no doubt think of a perfectly spherical object, perhaps one that has a lot of craters like the Earth's moon. But when you look at Deimos, as well as its partner Phobos, you'll notice that these moons aren't regular shaped moons. In fact, if you look at Deimos especially, you'll see various dips in its contour that makes it feel more like an asteroid than a regular moon, which again backs up the origin theories that were stated. This is curious for all sorts of reasons, not the least of which is that you could argue that Deimos is one of the oddest moons in the solar system simply because of its shape. Number 1. Colony material? While the world today doesn't seem like a very hopeful place, there are those who are striving for certain goals in the current decade that can elevate humanity as a whole. And the biggest of those goals is starting the Mars colony. Whether it's by SpaceX or NASA, man is likely going to set foot on the moon this decade. But what happens after that colony is started up? Well, many have asked that question, and many feel that it is very likely that either Phobos or Deimos could be tapped as special waypoint stations or mini colonies for Mars. The applications of these moons could be diversified based on the needs of the main colony, or the desire to further explore into the outer reaches of the solar system. The intent here in many people's minds is to not burden the main Mars colony too much. By putting colonies on the moons, it could act as a buffer to bring in supplies, or allow for easier launches into space, as they'd be truly launching off the moon instead of shooting right into space from Mars. There are a lot of ways this could work. It would just be a matter of intent, time, money, and the ability to build it on the irregular moons. Thanks for watching, everyone. What did you think of this look at Deimos, a truly odd moon? Do you think that this could be something for Earth to capitalize on when the time comes? Or do you think that more explanation is required? Let us know in the comments below. Be sure to subscribe, and we'll see you next time on the channel.